Okay, let's continue. Okay, so the second derivative we can just directly derive again from this one. So second derivative, this one is a 0. We don't need to write it, so let's derive this one. This one just minus pi squared cos pi t g plus minus from the derivative of cos pi squared sine pi t. Okay, here. For the first one, this is the answer. Have any question for this one? I think it's pretty easy, right? Like from the calculus one. Because you need to remember the calculus one, the chain rule and anything. For the drawing the curve, it's clear. Right? Okay. Let's move on to the second question. Okay. Anyone know the answer for this one? No one. Okay. Let's see from this equation first. This once again is a 2 part again, right? So x squared plus y squared is equal to 16 is a 2 with a radius of 4. So if we draw it in 3D, this one is x, y, z. This is a 2 here. And this one is cut by the plane where x plus c is equal to 5. So this one maybe is 5 here. 5. And this one, this term is cut by this plane. To draw it in x and c plane here. That's again 2D. X and c, you get a 2 here. This is a 4 minus 4 and 4. And this one is cut by this plane. This is c plus x is equal to 5. So you have to find the equation for the ellipse or the curve in the tube here. Something like this. So first of all, if we solve this one, we can just write as x is equal to sine t y is cos t here. But the radius is 4, right? If you square this one, then this will become x squared plus y squared is equal to 1. So we have to add 4 to this one. And for the c, we can just write this one. C is equal to 5 minus x. So the c is 5 minus 4 times t. Okay, for this one. To give you better image, I'll give you this visualization. As you can see, this yellow plane is x squared plus y squared equal to 16, and the blue plane here is the x plus c equal to 5. Maybe you have some question, what if we set the x is sinus or the x is cos? It's actually the same, but only a different of, what is it, the direction for the curve. So if we turn this off, this one is the x is equal to 4 sinus, and the red one here is x is equal to 4 cos t. But you have to make sure that the c is correct. So 5 minus sine and 5 minus cos t. Is it okay? Is it clear for this question? Do you have any question for this one? No? Okay. Let's move on. Next one. So the answer is this one, right? X is equal to 4 sine t, y 4 cos t, c is 5 minus 4 sine t, or you can just write it as okay. Let's move to next question. I'll give you 5 minutes to do this.
Huh?
Result 2 is almost correct. The correct answer is 1 over 3I minus 2 over pi squared g plus 2 over pi k. Maybe you have some miss on the integration part. Okay, let's discuss this one. So, if you have this one, then the integration for the r here, you can just integrate it just like the derivative. You can just integrate it part by part. So integration of t squared I plus integration t plus pi t g plus sine pi t integration. Okay, so just integrate this one just 1 over 3 t power of 3 from 0 to 1 plus the integration of this one. You can just use a partial derivation, partial integration, sorry. So t cos t, derive this one 1 0, integrate this one became 1 over pi sinus pi t, not pi sinus pi t. Maybe you have some miss on that. And the second one is minus 1 over pi squared cos pi t. Okay, and have any question about this integration? No. Okay, this one is plus minus, so you can just write it t pi t over pi sinus pi t plus minus times minus, so it's just become positive 1 over pi squared cos pi t from 0 to 1 plus this one just become 1 over pi cos, sorry, minus pi t, okay, from 0 to 1. Okay, and this one just become 1 over 3I plus this one sinus pi 0, sinus 0 is 0, so this has become 0 plus cos 1 minus 1 over pi squared minus 1 over pi squared. Cos 0 is 1, right? So minus. G plus 1 over pi minus 1 over pi. Okay. So the answer is 1 over 3I plus minus 2 p squared G plus 2 over pi. Okay. Okay. Have any question about this one? But reviewing calculus 1 again, right? Okay, if there's no question, then let's move on. Next one. Okay, do you get the correct? Do you get the answer? Anyone got the answer for this one? No. Okay. Uh, so the curve is x equal to ln t. From the question A, the question asks us about the point where the curve intersect the x and c plane. What is x and c plane? If you see here, x, c, well, this one is x and c, right? So x and c plane is where y is equal to 0. So from this one we can find the t for y equals 0. So 0 is equal to 2t minus 1. T is just half here. So we can just put the t back into the equation and get the points. So 2 minus 1. This became 15 over 8. And c is just ln 1 over 2. Or we can just write it as minus ln 2. These are all the points for the A. So the point is 15 over 8, 0 and minus ln 2. Yeah. Okay, with this one? Have any problem with this one? No? Okay, let's continue Q1. Oh, what's the question? The parametric of tangent line. So when you see a tangent line here, you have to derive this one, right, to get the tangent line equation. So let's write it again. RT is just 2 minus t power of 3 minus 1 and ln t. We can derive it as just like usual, so minus 3 t squared 2 1 over t. What's the question again? The tangent line at this point. So the point is 1, 0. When you see this one, you have to find the t, right? So let's find the t. So x is 1. This just become minus 1 minus t power 3. T is 1. So t is 1 for all of this. If you check it back, so the y is 2 minus 1. When the t is 1, we get 1. And t is 1, c ln 1, 0. Just like this one, right? So they are asking about this point when this one is t is equal to 1. Okay, so we can just put the t back to the r accent here. So the r accent t, or the tangent for this point, is just minus 3, 2, and 1. And this one is the direction, right? If you have curve, this one is this one. This one is r. So for the parametric equation, as in chapter 12, we know that we need to factorize. One is a point, and one is the direction. And so the parametric equation is 1 minus 3t, 1 plus 2t, and 0 plus t. This one is the direction. That's it. This one is the direction, and this one is the points. To review chapter 12 again. Okay. Have any question for this one? Okay. Let's move on to C. She is asking about the equation of normal plane. What is normal plane? If you have curve like this, then this one is the normal plane, right? This one is the normal plane. And from the previous one, we already knew about the tangent line here, or tangent vector, or t. So if you see here, then this r accent t here is the normal vector for our normal plane. This one. Okay, is it clear here? So you can just, and the normal plane here is just on the same point, right? Same point here. So you can just use the equation a x minus x0 b y minus y0 c c minus c0 is equal to 0. This one is the normal vector for the plane, and this one is 1 point, right, in the plane. So we can just write it as minus 3 x minus 1 plus 2 y minus 1 plus c is equal to 0. So minus 3 x plus 2y plus 3 minus 2 is equal plus c is equal to 0 plus b is equal to minus 1, and multiply both side by minus 1, you can get 3x minus 2y minus c is equal to 1. This one is the equation for this plane. Okay, is it clear? Have any question about this one? No? Then let's move on. Next question. Okay, let's directly discuss this one. So the length for the curve is integration from a to b, or the magnitude of the eraction dt. This is the formula, right? So we can just derive the r. This just become 3 to the power of 1 half or 1 half minus 2 sinus 2t 2 cos 2t. It's a simple derivation for this one. And we can find the magnitude here. The square root of t squared. So 90 plus 4 sin squared 2t plus 4 cos squared 2t. Here. Or we can just write it as sin squared plus cos squared. This just become 1, right? So, sorry, this one is 9. So this one just becomes square root of 90 plus 4. Okay. And we can integrate that one. So integration from 0 to 1 for square root of 90 plus 4 dt. We can use substitution. U is equal to 90 plus 4. Du is 90t. So integral from square root of u du over 9 from 4 to 13. If you put 0 and 1 back to u here, and this just became 2 over 3 u 4 of 3 over 2 from 4 to 13, and this just became 2 over 27 13 3 over 2 minus 4 3 over 2. We can just stop here because this needs a calculator to solve this one. Oh. Okay, have any question for this one? Okay, just reviewing calculus 1 for the integration part. The new things here is just this one. So can we new things from calculus 2? Okay, if you have no question, then let's move on to last question here. Okay, since the time is limited, okay, let's just discuss this one. So the unit tangent vector is this one, right? The t. What is the t? That's just eraction t divided by eraction t, the magnitude of eraction t. And the eraction t here is 3 sinus square t cos t minus 3 cos square t 3 uh, 3 sinus t and 2 sinus t cos t. And the magnitude of error action t is a square root of t squared, so 9 sinus power of 4 t cos square t plus 9 cos power of 4 sin square t plus 4 sin square cos square. You can just move the sin square and cos square out. So sin square cos square multiplied by 9 sin square plus 9 cos square plus 4, and this we can move out sin cos square root of 9 sin square plus cos square plus 4. This just become 1, right? Sinus square plus cos square. So this one just becomes sinus cos sin t cos t square root of 13 times square root of 13. Okay, and so the t, the t here is 3 sin squared cos minus 3 cos squared sinus and 2 sin t cos t divided by square root of 13 times sin t cos t, and this one just becomes 3 of 13 sin t 3 over 13, sorry, minus cos t, and this one just becomes 2 over 13. Okay, you have any question for the A part? No? Okay, and the unit normal factor of P. Let's make a new part. Unit normal factor versus this one. Oops, sorry. Unit normal factor is anti-1. This one just derivative of t divided by the magnitude of derivative of t. So we can just derive this one, the t, the derivative of t is 3 over square root of 13 cos t and 3 over 13 sinus t and 0. Right, the sin was okay. This is correct. So all positive, and the magnitude of t action just square root of 9 over 13 cos square t plus 9 over 13 sin square t. And you already know, right? Cos squared plus sinus squared just become 1. So this one just become the square root of 9 over 13 or just 3 over square root of 13. So the normal unit factor here is 3 square root of 13 cos t, 3 square root of 13 sinus t, 0 over 3 over square root of t. And this just became cos t, sin t, and 0. So let's write it here. Cos t, sin t, and 0. This one is the normal unit factor. Unit normal factor, sorry. And the C1 C is a unit binomial factor that shows pt, which is the cross between t and n, the normal and the tangent. So we can just cross this one. Cross with cos t, sin t, and 0. That is one. This one cos t, sin t, and 0. And this one just minus 2 over sin t, 2 over 13 cos t, and 3 over 13 cos squared plus sin squared. Or this just become 1. So the t is minus 2 over 13 sinus t, 2 over square root of 13 cos t, and 3 over square root of 13. Okay, the key part, T is curvature, the curvature of the curve. So K, T is curvature T here, and R. This one from the previous one, and we already searched for this one too. So this just become 3 over 13 sin t cos t. For the E, the tau is just T is equal to minus P times N T over the magnitude of R. It's all you already searched, right? So you can just finish this one by yourself. And do you have any questions for this one? I think the time is up, right? Okay. So if there's no question, then that's all for today. Okay, thank you.